In this lesson, you will find the percent of change and solve problems involving percent of change. So since we're working with percent of change, we should know what it means, and it is when an increase or a decrease is expressed as a percent. So what is a percent of increase? It is the ratio of an amount of increase to the previous amount expressed as a percent, and I'm going to give you a proportion to follow, like a formula that you can follow. A percent of decrease is the ratio of an amount of decrease to the previous amount expressed as a percent. So basically you're going to find the percent of change first and then say if it's an increase or a decrease, and I'll show you what I mean by that. So this is the formula we're going to use, and you have this in your notes. We have the amount of change over the original amount equal to the percent of increase or decrease, and we're just going to use a variable p standing for percent, over 100, which is 100%, and that's what percent means, is out of 100. So here's our first situation. How much is the change here? That's 3. So we're going to put 3, because that's the amount of change, over the original 20 is equal to p percent over 100. Now we're going to solve this like we did yesterday's. We can cross multiply. 3 times 100 is 300. 20 times p is 20p. We balance this equation, so we divide by 20, and checking my work here, we get 15 is equal to p. So this is our percent. Remember, p was standing for percent of increase or decrease, so you would write 15%, and then you have to look back here to see if it was an increase or a decrease. Original was 20, final's 23, so you would say increased, and if you want to abbreviate, you can. Let's try another. How much is the change here? Well, if you look, this is a change of 8. It doesn't matter if it's a plus or a minus change, it's just how much has it changed. That's all you care about. Original amount, 25, is equal to p over 100. We can use our balancing again with cross multiplying. 800 is equal to 25p, divide by 25, divide by 25. Just check my work here. So this is 32. So our answer is 32%. Now, is this an increase or a decrease? Well, if you look, the original was more than the final. So that's a decrease. So I'd like you to try a couple of these in your notes. Now, there is something I want to say here. There is another way that you could solve. You could do a times 5, what I call scale factor, and do 20 times 5 to get 100, so do 3 times 5 to get 15, and that's a little bit easier than the algebra. And in this situation, you could do 25 times 4. Well, then you'd have to do 8 times 4. You could use scale factor to solve these proportions and not use the algebra, but remember, we always want to practice our algebra, so that's why I showed you the algebra. Okay. Here's a real life situation. The total number of passengers on cruise ships has increased 10% from 2007 to 2009. So we want to know how many were there in 2007 if there were 17.22 million passengers in the year 2009. So we start with the let statement. Let x be the number of passengers in 2007. And I kind of want to leave this million out because I don't really want to work with it. So I'm going to say that this is going to be the number in million passengers that we have. So that I can just kind of cross that out and just work with the 17.22. So let's set it up here. Do we know how much they've changed? No. We don't know how much they've changed because we don't know the original. So we're going to take x minus 17.22. Because the way I find my amount of change is subtraction, and I don't know how much they've changed because I don't know this number. So that's why I have to put the variable in there in a subtraction. Okay, what was the original amount? The original amount, well, that was 2007. That was the original amount. Okay, so the original amount we don't know is equal to, now in this case, we know the percent, so we don't put a p here for percent. We know the percent, it's right here. So we put 10 out of 100 because it's 10%, and we keep the 100 the same. I'm using the same formula we just were using. If you're wondering where I'm getting this, same formula. Amount of change over the original is equal to p over 100. So we are going to then cross multiply here. Sorry, you're not going to use scale factor. You got to use the algebra. So 10 times x is 10x is equal to 100 times x minus 17.22. The reason I keep this in parentheses is because we're multiplying 100 times all of this, so I have to distribute. So I'm going to go ahead and do that first. So 10x is equal to 100x minus, I take 100 times 17.22, and we get this. Now I'm going to have to balance. I want to get all my x's together. Right now what we have here, I have x's on this side, x's on this side, and I have a number on this side. I want to get all my x's together, so I'm going to subtract 100x. And I know we're going to work with the negative here, but we just have to deal with it. 10x minus 100x is negative 90x equals negative 1,722. To get x by itself, we divide, because this is multiplication, by negative 90. Divide by negative 90. And you get x is equal to 15.65 approximately. You can round it. So this is our number of passengers in 2007, but remember it's millions. So we're going to say 15.65 million passengers in the year 2007. Okay, look through this again if you need to. Follow along with it again if you need to, and I'll have an example just like this in your notes that you can practice. Now, what about tax? I want to show you a shortcut to find the final amount using tax. Maybe in the past you guys have taken an amount and you found the tax of that amount and then you add it back in later. Well, I have a shortcut for you. Her merchandise is $28.62 before tax. And if the tax is 7.25%, I want to find the final cost. Well, here's what you can do. So you can do it in one step. You put a 1 in front of this decimal. 7.25% is 0.0725. You put a 1 here. And what happens is when you multiply, it'll take that $28.62, that whole amount, and then add this sales tax in for you in one step. It's really nice. Now, if you don't believe me and you don't want to use the shortcut, you can still do this the long way. Find the percent of this, add it back in, go ahead. But here's a shortcut. So we're going to take 28.62 times 1.0725. So you type that in on your calculator and you'll get the final amount out, which is 30.69. Type that in your calculator and check it and see if you agree with that. And then I'll give you a tax problem to practice so you can practice using the shortcut. It's a lot faster. How about with a discount? Well, yep, I have a shortcut for discounts too. Since Terry's are in grades in school, she gets a good student discount on her car insurance. So she gets $85 without the discount. She gets 20% discounted, so what will she pay? Maybe in the past you would find 20% of this and then you would subtract it, right? Well, that's 2 steps. I can give you 1 step. And what that is let's just find what the percent is that she's paying, right? If she gets a 20% discount, she's paying 80%. Think about it. So we're going to take 80% of this. So we're going to take 85 times 80%. You can type this in using percent key on your calculator, or if you want to convert it to the decimal, you can do the 0.8 if you want, that's fine. Either way, when you multiply, you get about $68, and I did that in 1 step. 1 step. If you wanted to still do it the old way, yep, you're going to have to find 20% of this and then subtract. You'll still get there. But remember, there's more than one way to get to Dairy Queen, and I'm driving, and you're going to be walking, but we're both going to get there, okay? So this is the shortcut if you want to practice it. I'll give you some discount problems in your notes to practice the shortcut.